Alright, at this point we're going to show what it takes to open up the ART13 in order to get to the AutoTune system for inspection, lubrication, and whatever. First thing has to happen is you notice the mounts here. These mounts have to come off, which is part of the basic bottom plate.
Oh, come on.
Okay, here is the model that we have for our Rockwell Collins Museum. It actually consists of the lower section of an ART13. All of the RF and the top part is completely removed. This is just for demonstration of the actual AutoTune. And one thing that it has its own little internal power supply to run the AutoTune. The AutoTune runs strictly off of 28 volts DC. That's all you need. This little demo is, you notice some of you may recognize this unit right here. It's the remote control unit for the ART13 that usually sits by the pilot side. We'll get into the actual switches later, but the ART13 has a switch called local and remote. When it's in the remote position, this controller is in command. So what we did here is take one of these controllers and wire it directly into the AutoTune system so that this is the controller. So when you turn the AutoTune on, you go from off to voice or CW or MCW, any one of those modes. Now the actual unit is on. And just to show you, we're sitting on channel 2. I'll rotate the channel selector to 1. And this is the operation. Now you noticed it took about 45 to 50 seconds for this to tune. Back in the 1940s, World War II, this is rather fast tuning compared to what they had with other systems in the days. It certainly is not suitable for fast tuning today, but here you had up to 10 channels plus a low frequency channel and a manual channel that all could operate within a nominal 45 to 50 second time period. Now, one thing that I'd like to point out is that you have the same dials that you had on the actual unit. This is it's a put together of following exactly the same format. You notice that each of the controls here has a big letter. This is the A control, the B control, the C, the D, and the E. These three being the RF tuners. And you notice on the E, it's correct. You have the dial that has the 2 segments, and as it in the reversal that you saw will be corrected. One thing that I'm going to do now is that I'm going to turn to the manual channel. You notice everything is rotating in a counterclockwise, and then at some point it reverses. The point where everything reverses is critical, absolutely critical to the operation of the AutoTune system. And what's happening here, every dial is going to go to its mechanical end. You notice that here, this is the mechanical end, mechanical end, mechanical end. And likewise on the multi-turn dial that goes beyond 20, these are the mechanical. Now each dial is completely free. You can select any band, any frequency, any tune configuration. The reason for this is that one channel has been provided, so if the operator wants to select a special frequency that's not on the list. One thing you notice about the front panel here is a chart that would be in the smaller upper right hand corner of every ART13. It lists all the 10 channels plus a low frequency channel if it's used, and it gives you the dial configuration of what was tuned at the time that this was set up. In this case, you've got 2 megahertz. The coarse dial A is tuned to number 1, which makes sense. Number 1 goes from 2.0 to 2.4. The fine-tuning dial, which is considered the PTO dial, has a number of 100. I'm not going to go through the complete tuning on these things, but for every increment of your multi-turn thing, like this is 19, and the next one is 20, there's 100 units between 19 and 20, which are the 100 units on the dial here. This is a multi-turn dial. So when one sets up a frequency, one sets it up to a mechanical reading. Now here's a copy of one of the pages that's in the book that's normally underneath the ART13 that has all the frequencies. That same information is listed in the TO, and you've probably seen that. It'll give you identical information. You notice right here, 52, this is the page that goes between 5200 and 5500, 5.2 to 5.5 megahertz. And you notice that there's a heavy bold figure. That's where you get one of the birdies. And without getting too deeply in the operation, you also have another one at 5400. So this gives you what you're setting up here is a mechanical number that represents a frequency. And by looking at this 5200, you notice the A dial has to be at 6, which is 4.8 to 6. Makes sense. You have to set the B dial to 674. So when you do that, now I'll run right down to where 674 is. And if you can see it, the small dial down here says 6, so that's 600. And then the upper dial, you go to 674. And at that point, we'll get back to the other panel. There'll be a calibration function on your ART13 that when you do the tune-up, you put it in the calibrate function. And as you rotate this around, this should be the center of a birdie. And say that birdie, so you hear a note, but it's too high. Okay, you run it, okay. Oh, your birdie is right there. Right there's your note. Well, you have an index dial down here that you can go off and put to 674. And basically what you're doing there is setting the index. Now this is your index just around that frequency. Everything you read to on the frequencies are related to the index way over here. So whatever number you pick, here's your index. That's just part of the tuning procedure for setting the thing up on frequency. Alright, what we really want to talk about what's happening on these dials here. I think that pretty much sets the way this is set up. Each one of these has been set up to a frequency, like 6 is 7200, and it gives a dial reading and so forth. All of these would be listed on the upper right hand placard when a unit is put in an aircraft and properly tuned. So now, talking about the maintenance of the AutoTune system. One thing that's essential for tuning, for alignment, is a hand crank. There is a military TO indication of a hand crank. I think that I hear all sorts of stories that people build all sorts of things, but here's a hand crank that was manufactured at my son, actually, who was a machinist, made that. What it is, it's a device that has a hole for a 6/32 screw, and I don't know if we want to cut and bring the camera around. Notice on the side cover here you have an opening in the casting, and there is the end of a shaft. There is a shaft that goes from this end of the casting clear to the other end of the casting that has worm gears for each one of the AutoTune systems. So when that shaft rotates, every one of the tuned elements rotate. The handle, if you look at this carefully, you'll see that there's a little notch on the opening of that thing, and your handle would have a couple of projections sticking out where they match up to the notches, like so. And then there's a 6/32 screw that goes into a threaded portion in the center of the dowel, the drive dowel that goes right across the entire chassis of the ART13. And what you do here is you screw this in and make sure that the little tabs line up in the hole. The reason for that, you're not just determining the force of your screw, but you've got a couple of tabs down in slots that make sure that this thing is rigid. Now, in the normal alignment of something like that, if you have a handle, the first thing you can do is start cranking. You notice the dials are turning. Now, if you see an excessive amount of drag here,
Jules, your student wants to feel that,
okay,
since this
that's a no. Go counterclockwise.
Okay, so you should only go counterclockwise.
And I'll explain the reason why in just a minute. See.
So I would turn that as very, very moderate resistance for those that are only going to feel one unit. I'm not pushing. We're talking ounces of pressure. It's a very light pressure.
But I should like to point out, Bill, that since we don't have any of the elements in here, we do not have the switching unit that has the
so you're turning,
switch.
In this case,
we're turning
less
against
pressure.
Nothing but the resistance pressure of the couplings and so forth. It's going to be a little bit more difficult whenever you have the elements, because you're going to feel you're turning, you're actually moving tunable elements throughout. The only thing that you're doing here is that you are actually moving the PTO. In this case, the only element that's to this is you've got your coils and your PTO.
Talk about the PTO again.
The permeability to an oscillator. By the way, as I pointed out, here's the oscillator tube. It's not there. But below that is the coils. This is the main tuning coil that sets the frequency. And you notice that this coil is non-linear. That the windings are spread in this portion, and they're not spread over here. Now, what happens at the Collins engineers, back when the time that this unit was invented, found a way to get a reasonably linear mechanical setting of a shaft to match a frequency change. So in order to get the numbers coming out linear on the dial, you know, where so many divisions equals so many kilohertz change, the nonlinearity is taken up in the design of the coil and the ferrite and so forth. That's all critical. That's a patented thing that was done back many years ago. And this same shaft also has two coils back here. These are one's for the first multiplier and the other's for the second multiplier. If I would show that capacitor, these coils are across the capacitor, and I'm going to, could you cut it for a second? Okay, now we talked about these two coils here. Each one of these coils is associated with a bank of capacitors that's on the multiplier unit, that's controlled by this A dial right here, the second dial over from the right. And that constitutes your tank circuit. You've got your inductor, you've got your capacitor. There's your resonant circuit. On each position of that, these capacitors are adjusted right in the mid-band frequency for maximum grid drive. And that's another topic here, the tuning to get the grid drive and so forth. But
And Jules,
these,
I won't turn these,
No.
but these capacitors are adjusted by moving this little tab.
that is correct, and you can do that. That's all right. I'll show it up. There's a little tab here, and you notice if I take that and rotate, I can rotate that. I don't know if you can see this good, but
Yes, I can see
see I'm rotating that.
the bottom disc of the
bottom
ceramic
disc
trimmer
is
is
rotating?
rotating. Yes.
Yeah, and then once again, caution. You got 400 volts right there on that tab. Never do it with an uninsulated screwdriver. There is a special tool that just, any one of the tools that has a fiber shaft, for alignment, and a metal tip on the end, that's perfect for this. So, much caution must be cared for whenever you do this kind of alignment. But that basically is an overview as to what's happening. Well, let's get back to the AutoTune itself. Before we get into the actual mechanical movement of components and so forth, I'd like to take a few minutes just to run over the electrical operation system of the AutoTune. You notice here in the diagram you have an item. This is the motor. You have a reversing relay. The reversing relay is down under the casting here on that side, and we'll show that later.
Wait a minute. Do that again. Where's the relay?
There is a reversing relay which is
I
on
can
this
see
side.
it. It's right here.
We can look at that later, but it's on this side of the unit down there.
Okay.
And now, what you see before you, this area here, shows two switches. The upper switch here is one S111. That's this one. The other one is S112. These are critical to the operation of the AutoTune. And also, it shows you the extension of the wiring. Here is what happens with the tuning. You have a switch here that is all shorted except for one open contact, and that's right on the back side of this A dial, and we can show that later. Then, of course, this other switch here would be the selector switch, which would be what you have on the front panel when you select a channel. Now, basically, what happens is this. The AutoTune rest position is whenever this S1 is up in this position and this contact is tripped open. When you select a new frequency, we're assuming that you've been properly selected. And you notice over here it shows number 10 with the open contact. This shows that the unit was at channel 10. Now what happens is you come in here and you select a new channel. And when you do that, it provides a ground on whatever line you're. If we go to 9, it provides a ground on the number 9 line because of the fact that you've selected the 9th channel. It comes over here and it's a ground. What it does is it takes the common of this switch, which is let's see. Hold it a sec. Oh, got it. Pick it up.
Okay.
The ground is right here. The center, this whole frame here, it's got a ground center. So what you've done is you've provided a ground line on this line that goes back up to this area here, and it actually energizes the relay that turns the AutoTune on. And all the dials start rotating in what's known as a counterclockwise direction. What that does is it drives this fixture here, and you notice in the back side there's a threaded, it's like a worm gear. This starts going down toward the opposite side until the S111 opens. What I'd like to point out is, before we get to that point, that this relay, this coil, is being held in by two grounds. During its energized position, everything is going in a counterclockwise direction as far as the dial rotation, going to the in travel. And since this, if you trace through the whole schematic here with the relay, you'll find out that there are two grounds holding that relay coil. One ground is this, and the other ground is the ground that you see from the S109 selector, which is on the back side of the A dial, which you'll see later. So both of those have to open up. The first that opens up is this S112, which is this one right here. As soon as this contact opens up, then you've removed one of the grounds. And the reason you have that is because without that, every time this goes around once for every rotation of the thing, and you'll have many opens and so forth, and many satisfied conditions. So this inhibits that relay from de-energizing until you get down to the point where this opens up. And now the first time you have an open, you'll see the open on the channel 9, because that's what you selected. As soon as that happens, that relay relaxes. As soon as it relaxes, your AutoTune goes in the opposite direction. Now that's critical. The most important point in the alignment of the AutoTune in operation is that exact point where the AutoTune reverses. And to that, we can get into some other discussions, but if you notice that the motor itself is always connected, if you look at the plus, it comes right up here to the motor coil, and the ground is the other. That field is active all the time. It's got 28 volts on it as long as that unit is on. And some of the hams have gotten off, and I've seen literature where they've said, oh, we can put a couple of diodes and so forth. Don't ever do that. Don't ever do that. If that motor coasts beyond its reversal, what happens is it'll never find it. When the motor is reversing, all of a sudden it coasts. When that relay relaxes, that motor's got to freeze. And then the polarity of the motor is changed, so the motor reverses in the opposite direction. That's the most critical point. One of the units that we had to repair, it took me about 2.5 hours or 2 hours to figure out why the AutoTune, every time it went to the end, it kept doing funny things. And it's because somebody put some diodes in there. They didn't know. And as a side point, if you've got a really stiff, unlubricated system, in fact, I checked the unit when it came in, and the AutoTune worked just fine until I lubricated it, and when that was all done, it didn't work anymore. The stiffness of the gear train was going to freeze the motor too. If you've got a good working gear train, that motor is going to... That's why they keep the coil, even when the thing is at rest. You know that there's a 100 ohm resistor, so that the coil, so that the armature still has a field, very small field. It's all part of the braking system. It's very important. Okay, with that you kind of get an idea of the total operation of the AutoTune electrically. Now, if we come back, let's quit.
Mention where you find this diagram.
Oh yeah, this is the diagram of the TO, the signal core TO. Bear with me, I'm going to read the name now. the TO number is 12R2-2ART13-2. This is a signal core repair manual. Most of these things are out there. The boat anchor bomber site has them. And I think-
Downloadable copies, yes.
And they, people are selling these on eBay and so forth, but it's not too hard to locate a copy of this.
I downloaded mine from Bama,
And you got errors in yours.
which you'll help me correct,
Yes.
correct? Thank you.
Yes. All right. We select a new channel. Notice all dials are in the counterclockwise direction. This is driving down toward the opening of this switch, and you notice there'll be a slight hesitation. It's open, and you notice what's happening is that the second switch is on the backside of this dial, had to find its open contact. It reversed it precisely that time, and the proper pawls dropped to the proper positions at that time. That's part of the alignment of the AutoTune system. Now, would you want to take a picture of this?
I think just describing it, I'm not sure how much we're going to
I
see.
can hand.
Well, let's see what you...
Okay, now we're on the air.
All right.
Go.
All right. In this discussion, the open seeking switch that I had mentioned is on the back side of the A dial. This is a close-up view of that switch. And what I have is I have my pointer here pointing to one which is the open segment. And what we're going to do is, Bill, you go ahead and off and back to the same channel, just so that we'll be there again. Good. Now you notice that you can see that the open sector is scanning around. And there it is. It stops right at that same point, and that's critical. And I might point out that if you look at that closely, you find very little area on each side of the switch. That is why if you have a motor that goes just a little bit, it'll never tune. That motor's got to break instantly when it returns, when the reversal. It can't trip. One of the most critical spots of the operation of the AutoTune.